Thank you everyone for joining and welcome to our talk, the Conan Package Manager in Practice. My name is Jerry Wiltse and I'm a Conan developer at JFrog. So the link and the QR code shown here in the slide will take you to all the resources for this talk. The slides will be posted there and the video, and you can also rate this presentation and enter a raffle to win a Conan t-shirt. So we will now post the link to this in the Zoom chat for those interested. Winners will be contacted by email in 2 business days. The t-shirts are really great, so I suggest you sign up if you want one. For the exercises here, I've created a reproducible environment which contains all the files that will be used in the examples, and I will use this environment to run the commands myself. The goal of this environment is that anyone can clone this repository and run the exercises on their own. The commands will all be contained in the PDF of the presentation. So that should be all you need to get started. Of note, it's based on Docker, so you'll have to have Docker installed. But if you have Docker, everything should work, whether you're on Windows, Mac, or Linux. If you try things out and you have any technical difficulties at all, please feel free to open a GitHub issue on the repository or reach out to me directly. It should be pretty easy. So I prefer to see code and examples, but before we do that, I do want to give a brief introduction to Conan. If you don't already know, Conan is a package manager for C and C++. It's open source and it's published with an MIT license. It's multi-platform, which means it runs on Linux, Windows, Mac OS, and a bunch of other platforms, basically anywhere Python can run. It is designed to support all the popular build systems in C and C++, but also to support custom build systems, which is not uncommon in large enterprise environments. So a lot of people have cobbled together shell scripts or written really nice Python-based build systems for C and C++ for their company, and Conan has great integrations for that. Conan is stable, which means that we don't do breaking changes within major versions. So packages created in Conan 1.0 will work within Conan 1.0 for all future versions. And if there's a breaking change, it won't be released and added to Conan until Conan 2.0 is released. So Conan is also a very active open source project. It has several full-time developers sponsored by JFrog, as well as an active user community, which submits dozens of pull requests each month. And we have currently 1,200 members, over 1,200 members in our Slack channel in the C++ community. It's one of the most active channels in the entire C++ community Slack. Finally, the Conan team has created multiple interactive and self-paced training courses for new users who are trying to learn Conan. They're available completely free, courtesy of JFrog on the online training platform known as the JFrog Academy. The link is here. We can post that in the chat as well. These courses go from beginner to advanced, and there's even some new courses coming up for continuous integration with Conan and other advanced topics. So in fact, a lot of the content from today's talk was borrowed from some of those courses. The high-level design of Conan is fairly standard compared to other well-known package managers such as NPM or PyPy or Maven or apt or yum on Linux. It features common concepts like a local repository, which will be used for local package operations, and then remote repositories for sharing packages with easy-to-use upload and download commands and capabilities. So that's a very familiar experience. There's also, just like many other package managers, a central moderated repository with common open source packages, which is known as ConanCenter. Currently, we have over 700 open source libraries and applications mixed between C and C++ in ConanCenter. So if you're interested in open source libraries and projects, you can check that out. So Artifactory is a server application which is provided by JFrog, which can host Conan repositories. And that's what we'll be using for the exercises today with respect to uploading and downloading packages. Also of note, ConanCenter is simply a Conan repository hosted on Artifactory in the cloud. So the hosting and the moderation, again, all provided by JFrog. So while Conan is similar to other package managers in its high-level architecture, it's very unique in its package model. The string shown in the box here, PKG 0.1 at user channel, is an example of what we call a recipe reference. Now, this is the most simple and logical identifier there is for a package in Conan. And one of the unique things about this recipe reference, though, is that it can represent any number of separate physical binaries with unique build configurations. So this package model, in which a single identifier represents any number of unique build configurations, this is one of Conan's major innovations. Now, here's how it manages to do that. In simple terms, Conan assigns a unique ID for each unique configuration. So in this first box here on the right, we see that the compiler is Apple Clang, and the version is 8.1. It's Mac OS, and it's a 64-bit configuration. So that this is calculated. All of these variables that go into the unique configuration are taken and hashed together to compute this unique ID, which is called a package ID. And Conan uses this unique package ID for various things throughout the packaging process. For example, it's a fundamental part of directory structures that store the packages. It's a unique string, so it works as a unique folder name, and so forth. And as you can see, any change in the configuration, so for example, the first box has build a shared library set to false, and the second box has an option for build a shared library set to true, will have a different unique package ID. So the first one will be a static library version of some package, and the second one will be a shared library version of some package. And they will be stored separately, and you will never have conflicts, you will never have overwriting and things like this. So this package ID concept is very fundamental to Conan, and it's another one of the major innovations. And the great thing about that is that the client and server can also use this package ID as a matching mechanism when requests go out to upload or download a binary. So for most of the operations you do in Conan, you're specifying a build configuration. And with this configuration, the Conan client will calculate package IDs for the packages, and it will use them for various interactions with the server. So when you request, in this case, GCC on Linux version 9, the release version of a binary, it will only download that binary, and you won't have to download the debug version and any of the other binaries that are up there for that particular package. You can only download the one that you need. So it's really neat. And then also with your local cache, once you've downloaded this specific binary for a package to your local machine, that binary can be used across any number of projects on the same machine, assuming they're requesting the same configuration. So basically, there's no reason to rebuild the same binary multiple times with the same configuration, which is kind of a very inefficient thing that happens in a lot of developer scenarios where you're building everything from source all the time. And a lot of times the complexity of optimizing away redundant builds doesn't outweighs the cost of trying to figure out how to optimize it away. So it's Conan does that by default natively, and it's a great feature. So one last innovation I want to talk about before we get to the exercises is the way that Conan abstracts over build systems, which makes it much easier to consume, but in particular, open source libraries and projects. So when you're developing applications in a team, it's a typical requirement that each developer should be able to build the entire application, including all of its dependencies, from source. Unfortunately, many C and C+ libraries and applications have multiple open source dependencies, and those dependencies have other open source dependencies. And unfortunately, any of those can and do have unique and complex build systems. This is a major burden for C and C++ developers who want to focus on the code and not the build systems, is to have to learn and understand enough of these build systems to build the library just so that they can use it. Conan aims to reduce this burden on the developer so that once an open source project has been packaged with Conan, Conan users no longer need to interact with that build system directly to use it. Instead, users just install such projects with the Conan install command, and Conan handles the interactions with the build system in the background. So you can absolutely take a package from something like Folly or Boost or OpenSSL from ConanCenter, and you could say install it, and you can use precompiled binaries if they exist. But you can also pass the -- build flag, and you can build from source, and Conan will invoke B2, the build system for Boost, or automake and make for OpenSSL and auto tools. So, or it'll invoke Bazel for Absale if need be. So all of that, though, the developers no longer need to know how to do those commands and run those build systems manually just to get the libraries into their project. So that's a big win and a big part of the value of a package manager in general. So we have an exercise here. And that exercise is to show that particular use case. So we're going to demonstrate a seemingly simple goal, which is to use an open source dependency from ConanCenter. We're going to use it in a common build system project, a CMake project. And it's also worth noting that the dependency we're going to use today is Boost regex. And that's relevant because Boost libraries have historically been non-trivial to get and to use on all platforms in a way that is general and, streamlined and easy. So we're going to show how Conan makes that easier. And the key command that you should take away from this exercise is the Conan install command and how easy that is. Here are the relevant files for the exercise. It's actually a real application that works. So first we've got a single source file named regex.cpp, and that includes boostregex.hpp. Next, we have a file named conanfile.txt, and this file is the most simple and declarative way to use Conan to provide dependencies to your project. In this case, we declare we need Boost version 1.7.4, and that in this generators box, we show that we are using the CMake build system. More specifically, we are saying that we are providing the dependency to our project using CMake's find package feature. There are a few ways to get dependencies inside of CMake. We're going to use the find package one because it is the most commonly used. And then here we have the CMake lists file. If you don't use CMake, this is a simple example of the build system file. We can see that we're indeed, it builds the regex.cpp, and up here we see find package boost, and very specifically the regex component is what's required. Notice that this CMake lists does not contain anything specific or proprietary to Conan. We don't call any specific Conan files or reference any functions. This demonstrates that using CMake projects using find package, you can now use dependencies from Conan without any modifications to your build system files. And this is noteworthy because the Conan team has had to work very hard for several years now to achieve this capability of complete transparency with CMake find package specifically. Even a year ago today, you had to make some modifications, and a lot of the packages didn't work exactly as expected with CMake find package. And this was a big source of feedback from our users. And now we have here the simple example showing that it is possible. Okay, so here are the commands on screen. I'm going to walk through them real quick, and then I'll run them in a terminal, and we can see if they're actually going to work or not. Just some simple setup of directories here. We make a special directory called build Linux, and then we run the Conan install command, passing a profile which contains the configuration that I showed earlier with regards to GCC version 7 on Linux. It's the release build. So the profile is another feature we won't go into today, but it contains the build configuration. We use a shell script, which again, we also won't talk about, but we do explain that in our courses on the JFrog Academy. So if you want to learn more about that, it basically sets environment variables, that's all. And so that the following CMake command, where we build release, can actually find everything it needs. Notice this, this flag here for CMake, which says -d CMake module path equals pwd. That is because the Conan install command will generate CMake files for find package, and we need to tell it that we put them in the current directory. So, but after that, everything looks very normal. We just run CMake with -- build, and then we run our application, which comes out named regex.exe. And we pass it this little string, subject, regarding Conan, and the application, it's a simple program. It just transforms the output to say what this email was regarding. So it's an email subject, and it just sort of does a little text transformation. And then we have a couple cleanup commands down here to put us back for the next exercise. So I also have a note here. We're not going to run this bottom command today, but as I said before, when we install a dependency from a remote with Conan install, very often it is necessary or desirable to build from source on the current machine. Maybe you have a custom modified version of GCC 7 and you want to test those, or you're doing something, you want to make sure it was built from source. You don't trust the binaries on the internet. One of the best parts about Conan is all of the recipes contain all of the instructions to build. So you can do a simple -- build flag and specify all or specific dependencies in the graph, and it will build those ones that you have specified, and it will all be transparent, and it will all just take a little longer, but everything will be built from source. So it's a very cool feature and very necessary when your language wants you to build from source a lot. So I will now do the git clone, and I will do the Docker setup of this little environment. And that will take a moment. And not as long as I expected, though. Okay, so now we're going to get into a bash shell in our demo environment. I'm going to go to the find package example directory. I'm going to make a directory and cd into it for the build on Linux. I'm going to run that Conan install. This is the operative command. So we're going to see is Conan is going to download all of the dependencies that we specified, and it's going to install them. So here we see boost 174, and it has found it in ConanCenter. Now, what you might not realize, if you're not familiar with Boost, is that Boost has other dependencies of its own. So we see here in the logs, zlib, bzip2, libiconv, and OpenSSL were all downloaded as dependencies. I think OpenSSL comes from CMake, but
Jerry,
yes.
Is it possible to make the font a little bit bigger?
Yes, thank you very much, Ari. I've forgotten to do that.
There you go. Thank you.
So now it is downloading and decompressing Boost. And if you've worked with Boost, you might know that sometimes when you download Boost, it could be 400 or 500 megs, depending on if you get all the sources or if you get binaries and things. But here, hopefully I didn't miss it, but right here I've highlighted that it's downloaded a 20 meg tarball, which is, so that tarball contained the lib files and the headers specific to our configuration. So much smaller, you're only getting the binary that you needed and requested given your configuration. So instead of downloading the whole of the source and all of that, we just had to download the 20 megs of precompiled binaries. So that's a great feature. And Conan gave us a nice printout of the important work that it did, which was to generate CMake find package files for all the dependencies in the graph. So this is what that CMake find package generator does, is it produces these text files. It also produced, as I said, excuse me, the script that we're not going to go too detailed into, which is activate.sh, which sets some environment variables for Conan. And then we are going to run CMake. And we are specifying build type release, and we're saying use these .cmake files in the current directory that Conan generated to find the dependencies. And it did. It was successful. If you know CMake, it's a very verbose logging. I don't expect anyone to read all this, but the key is that when we do CMake -- build dot, it does in fact successfully compile our regex program, and we can run that with a string argument of subject RE Conan, and it will say regarding Conan. Okay. Any questions so far on this example? I will bring these slides back up to just sort of recount what we did.
I'm guessing the size was very small because this was a release build and not fully optimized. I'm guessing like a debug build would be much bigger, right?
Potentially, yeah, I suppose, yeah. But I don't think it's bigger, probably, but not that much bigger. I suppose it depends on the application, not our regex program, but a real program probably. Okay, so now one of the important things about Conan is that it is cross-platform, and I think many developers have tackled the challenges of getting their dependencies on their platform of choice, their favorite developer platform, whether they're a Linux developer and they use Ubuntu or Debian, so they use apt to get their dependencies a lot of the times, or if they're a Mac developer and they get things like Boost or something else through Homebrew. A lot of times it's not that completely overwhelming to get dependencies on your platform. But it becomes a much bigger challenge when you have to develop for multiple platforms. And now you have to get the same dependencies with very similar configurations, you know, and have some sort of uniformity around cross-platform development. That's another tier of difficulty and complexity. And that's where a cross-platform package manager like Conan really shines. So now I'm going to run the same exact build, but we're going to do it on Windows. So on this terminal, I have Windows. So I will go to Conan CPP demo, which we already checked out. I will go again to the find package folder, and I will now make a directory called build Windows. And I will again zoom in on this side. I apologize. Let's see if I can. Let me do this a little bit. I'll just push our Linux to the left. We haven't forgotten about it. It's over there. And under build Windows now, we will Conan install. But this time we're going to use a profile, a Conan profile, which is set up for Windows, Visual Studio 16 in the release mode as well. And now in Windows, it will effectively do the exact same process, but with a number of implementation differences. Because we're on Windows, everything is taken care of and abstracted away for you. We still get a bunch of find package CMake files, and we still run a script that sets some environment variables, which Conan provides us. It's just a bat file instead of a shell script. And when we run CMake this time, and actually, I'm gonna go full screen. We tell, again, CMake module path is the current directory, but there's an issue with backslashes and forward slashes, but it's fixed. And here we're going to build on Windows with the exact same process, the same steps, the same you know, logical flow of developing on either platform, and that's the big benefit. So here we run the CMake build. On Visual Studio, you have to pass a configuration. We want the release build and not the debug build. And we should now have an executable called regex.exe. And I will do that again. So here we get our successful response regarding Conan. I feel like I zoomed in a little too far. So yeah, so here is where the VCX proj from the CMake Visual Studio generator produced the executable. And here we run it with this path. So you get the cross-platform experience. Hopefully that makes sense. Any questions about that? The differences between the two platforms, perhaps? If you're interested in the scripts, these environment variable scripts that I'm talking about, please make a note, and we can, you know, we've got lots of Q&A time scheduled at the end of this talk, so we can go into more detail at that time if you like. I've got some questions in the chat. These are great questions. There's a question about, does Conan support native Visual Studio and MS Build projects instead of CMake? Yes, we use CMake here for demonstration because it's sort of widely used, and it's also cross-platform, which fits nicely for demo. But we have extensive support and helpers and built-in custom classes for Visual Studio and MS Build, very similar in nature to CMake. And then also another question, and then also others. So Auto Tools, we have a bunch of helpers. Meson build system, we have helpers B2, even QMake now, and QBS, I guess. So we have a lot of different build systems that have first-class support. Can you speak a little bit about the conventions of build names, such as debug release, compiler choice, etc.? How is one's library naming does get paired with others? And that is a great question. That is a deeper answer. So I'll save that till the end. We'll circle back to that question later. So thank you, Roy. And thank you, Diego, for posting additional information in the chat. Oh, so here was the commands for Windows. I just want to point out here were the differences highlighted in green. You know, we used a different folder, of course, because we don't want to conflict. We used a different profile. The activate.bat, this should have been highlighted green, as should this line down here. But, you know, the key is just the slight shell differences on Windows and Linux. But overall, process was very uniform. So I just want to recap what we talked about. Let me see here. So Conan install is the operative command to get dependencies from Conan and use them in the build system for your project. It can be completely transparent to your project. You're using some mechanism today to put dependencies in your project. You can transparently insert Conan into that process and get your dependencies from Conan as well. Conan makes the process simple, even for complex dependencies like Boost and Qt even, although Qt's more difficult and complicated. Qt is available in ConanCenter now. Again, Conan can provide these to any build system. And this includes CMake, which, to be honest, has the most sophisticated dependency management features of all the build systems. So that's worth noting. And finally, ConanCenter provides a number of packages for popular C and C++ projects, which includes a lot of precompiled binaries for a lot of these platforms. I think we have over 100 precompiled binaries for different configurations for our open source projects in ConanCenter. However, despite the precompiled binaries, it's extremely important to note that even particularly in professional development environments, using precompiled binaries from ConanCenter is not necessarily recommended, certainly not if you're going to ship to customers. You should build from source, and Conan makes it trivial to build from source with the -- build command. And then once you've built locally, you can upload to your remote, and you can use only binaries that you built without having to rewrite your own recipes or anything like that. So highly, highly important part of consuming is the build from source feature. The next thing we want to talk about is the Conan recipe, which you may have heard of. I think I've mentioned it. First, we're going to explain quickly what it is and show some examples of them. But in simple terms, a Conan recipe is a Python class which Conan will read, and it will execute standard methods in a certain order to create the package. So rather than try to explain that better, we'll start with an example here. This is a skeleton example where none of the methods have bodies defined. We just want to show what the structure of the Conan file is here. As we said earlier, it's a Python class. If you're not familiar with Python, it's fairly easy to learn, in particular, just to learn what you need for a class like this. These method names all correspond to standard steps in the general building process for a C++ project. So for example, in the requirements method, we define the dependencies we need. That's something you need to do. The next method here is named export sources. That tells Conan how to capture the sources that it's going to build from, whether they come from, there's a couple other ways you can get sources into Conan. You can get them from Git repositories, URLs, or your local folder. So Export sources is a way to just copy all the files in the current folder and use them as the seed for the build. Next, we have a generate command. This is actually kind of a new command, a new function that has been pulled out of the build function. It used to be an implicit part of build, but now it is a dedicated function which takes Conan variables and puts them into those CMake files or .props files for MS Build or .make files for if you're using make build system. So generate is a method designed to take variables from the Conan dependency graph and put them into files for your build system to use. Build is the method that obviously invokes your build system. So it's going to read the generated files from the generate method, and it's going to use those to say run cmake -- build, for example, or ms build or whatever. The package method is used to capture whatever the artifacts were from the build method. So it would be .lib files, .a files, .so files, or executables. So it's very common. I'd say the most common case is packaging up libraries. And so you think about libraries feeding other libraries. But eventually, when you're building executables or shared libraries that you plan to ship, you capture those into a package and you can use them. And that's what we'll do in our next demo. Now, the last part, which is actually fairly interesting and really another cool innovation of Conan, is this package info method. And what it does is it defines everything that other packages which use this as a dependency, will need in order to consume it. So for example, a list of all the .lib files or .a files, the directories that those files are stored in, the subdirectory structure of the package. Also the directory names for the headers. A lot of times headers are in a folder called include. Sometimes they're not. Sometimes they're in a folder called inc. Sometimes they're in a folder called headers. And so each library has unique, the ability, the freedom to have this package structure however it wants. And package info is where you declare what that structure is in a generic way so that consumers don't have to know anything about you to get your headers and your libs. And there are other variables as well. Those are just some. And finally, Conan will call all of these in the appropriate order, depending on the command you run. So now here's an example where we actually filled in some of the methods. Someone pointed out, interesting that the functions get 0 arguments. Actually, to be perfectly accurate, they take 1 argument, which is self, which is the Conan file, and a lot of the self object in these methods contains a lot of power and capabilities. So there's a lot of functions that are attached to the Conan file class. There are a lot of data members that are attached to the Conan file class. We use 2 of them here. So you'll see more that they have a lot of power in scope inside these methods. All right, so in this particular example, we have the CMake, it's a CMake project, so we take advantage of several CMake specific helper classes that we provide from Conan. And it makes the recipes much easier to read and write than the alternative, which we'll show next, an alternative where we're using something that's not CMake and we don't have the helper classes. But here are some of the, here's some of the methods. So we have export sources, and this self.copy star states that we're going to copy all of the files in the current directory into a source directory. Maybe that catches a README and some other stuff, but we're not, you can make this as precise as you want. But for this simple example, we're just copying star. So we're getting all the sources and headers, and we're putting them in a source folder. As we said before, we use the generate method to take information from Conan. So for example, this toolchain helper generates a toolchain file, which has things like the architecture, preprocessor definitions that you need to define for just this project. And it puts them in a CMake file. And then the CMake deps helper here produces those files we saw earlier, findboost.cmake, findzlib.cmake, etc. That's where they get generated, is in this method. Next, when we call the build system, we have a simple CMake class. It has a configure method, which corresponds to what we did earlier, CMake, -d toolchain file and so forth. And then CMake build corresponds to CMake -- build dot. And these have parameters, and these are just the most simple cases of these helper classes. Now, we talked earlier about the package method capturing artifacts that are output from the build. Well, interestingly, we'll show next the manual way to capture those files. But first, we want to point out that with CMake, for example, a lot of CMake projects define what's called an install target, which already tells CMake what files are coming out of the build and where they would need to go in any destination when they're installed, when you go to use those CMake packages or CMake projects. So here we have a method on our CMake helper class called install, which corresponds to CMake with the -- target of install. And that reuses the logic that you've already written into your, or the project has already encoded into its install target. And it just executes the install target, which copies the files on Conan's behalf. That's a little esoteric perhaps, but it's important, and you'll see this a lot in ConanCenter recipes. So rather than us defining what files need to go to what destination directories, we let CMake recipes tell us that, or CMake build system to define that, and we just invoke the CMake build system. Now we do need to complete the package info step manually. So here, for example, CMake doesn't know anything about this step that we do for Conan. So we define a list of include directories, which is where our headers are going to be. And we're going to say that those go into a folder named include. And we can have any number of include folders, and they'll all be passed to the compilers later with the -i flags effectively. So we also pass the list of directories where we're going to store lib files in this package. So by convention, it's very often lib, but it can be anything else. And then we're going to provide the list of libraries to link with. So whether it's mylib.a, libmylib.a, or mylib.so, or on Windows, whether it's mylib.dll, this is the sort of abstract name of the thing. And Conan will translate that into libmylib.a when it passes it to the, well, it has some logic for deducing what needs to go to the linker based on this list. So this is the abstract definition of what consumers need to use the mylib project. Now here's an alternative Conan file example, one where it's not using CMake. And I'll just focus on the parts that are different. So all of this stuff. So first of all, the generate function. So if you're using a custom build system or some build system we don't support, you'll still need to get the information about the Conan dependencies into text files so your build system can read them. And one of the great features of Conan is extensibility. And here you can write a custom function or a custom class in Python, which will take those variables from Conan and put them into a .text file. You can name it customfile.text. If your build system's written in Lua, it could be Conan buildinfo.lua. But Conan gives you flexible ability to generate any text files from the variables that a build system would need. And then when you run your build system in the next step here, the build method, you call your custom build system. Some way you need to pass the name of this text file, which contains the variables that Conan delivered for you. So this is part of the extensibility model. We want to show it here. Some open source projects have custom build systems. And so you'll see some pretty convoluted Conan recipes to capture that. The beauty is, once someone's created that recipe, nobody else has to tangle with that build system again just to use that library. So that's the good part. Now the package method we have down here, we don't have a CMake install method as we did before. So now we have to capture all of the files that consumers of this library would need manually. So you can see here, explicitly capture all H files and we put them all into an include directory. We copy them from a directory called source. So the self.copy method has a lot of good optional flags. It's a very flexible command and it includes wildcard support. So we can copy all DLLs to a bin directory, which this would be important on Windows. We also capture all .lib files, put them in a lib directory. For Mac OS, we capture the dilib files and we put them in a lib directory. And on Linux, if it's a dynamic library, it's star.so. If it's a static library, it's star.a. We put all of those in a lib directory as well. So this package method would capture all of the artifacts on any platform you built this thing on. So you have a little more verbose method definition here, but the idea is the same. You just need to get all of the artifacts out of the build directory and put them in a package folder. And Conan, it lets you do that in a very flexible way. And then the package info method is the same because the sort of generic definition of what consumers need to know about mylib hasn't changed. How we built it, how we captured it, all that may have changed, but what it defines for consumers is in theory the same. Okay, before I jump into, there's some good questions already going on in the chat. I want to say if it's a good opportunity, if you have an additional question about this case or about the Conan file in general, please feel free to post it in the chat and we'll come back to it at the end, I guess. Okay, so for this exercise, we're going to take the same project we used in the first exercise, but now we're going to package it. So instead of conanfile.txt, we're going to delete that, and we're going to use conanfile.py, which allows us to define a full recipe with all of the methods. So we're going to use that, and the operative command in this exercise is conan create. Just for a reminder, here's our source file. It's exactly the same. Conanfile.py, it's a little too large to put on this slide. We'll show it in the next slide. But again, the CMake lists is also the same as before. So this Conan recipe is a streamlined version of the CMake example that we showed just a minute ago. It requires boost 174. We say we're going to use all sources. We're just capturing all the sources in the current directory. The build and package method are exactly as they were in the previous example. We do CMake configure and CMake build, and then we run CMake install to capture the package contents. Lastly, up here, I do want to point out the generators equals CMake find package. So this is an older syntax of the generate method, which the generate method is still currently under a little bit of development. So for this example, to keep it simple, we just define using the old syntax of an attribute up here. And we also still want that virtual env generator, so we've placed it here. Okay. Give me one moment, please. All right, so we've got the commands here, very similar to before. We go into a different example directory, and then we run the Conan create command with the same profile as before. That part's the same, but the Conan create command says, create a package from the current directory from scratch. So then afterwards, after we create the package, we're going to demonstrate running the executable from within that package so that we can test it and prove that it worked. So we're going to use the Conan install command, very similar to the way we did in the first example. And we're going to run Conan install the regex. This is the full now recipe identifier I mentioned earlier, the recipe reference. We're going to Conan install our regex package, and we're going to use the -g virtual run env generator, which is another feature. And we're going to pass the same profile we did before. We're going to use another one of these virtual environment scripts and run the application. And we're going to, this particular virtual environment script called activate run, it's specifically designed to make available the application that was, which for the package you just installed, all of the bin directories, which is where we capture the executable, it will put them on the path. So in the next line here, you see when we run regex_exe, it actually runs the executable from the path in the Conan cache where the package was captured. And so let's do that exercise now. Okay, sorry about that. So we're going to go to the examples, create package directory. Oh, so now I'm going to go back to our Linux shell. And we're going to get a clear screen here. We're going to run we're going to cd back to our, we have a create package folder. We're going to run the Conan create command as we said before. There's some syntax things here I won't go into. This demo/demo, it gives an identifier, but the other part is the profile. And we say that the Conan file.py is in the current directory. So we run this. I'm going to briefly go and show the log here for a second. It's very largely the same as the log from our first example. It just has a slight difference. Unfortunately, again, CMake is very verbose. Okay. So it started by calling the export sources method, as we said, and that prints out a nice list of everything that was copied and that will be used in the build. It also prints out the configuration that was used. So this is the profile that we specified. You know, here I just specify it by name, Linux GCC 7 release, but here it shows the precise variables that will go into the build and the package ID calculation. So you can see it's much more complete, and that's very helpful for debugging and so forth. And here it's saying this is going to be the recipe reference that it's going to build. And so regex 010 at demo/demo. It also summarizes all of the dependencies. So here were all of the dependencies, and it explains that it's going to try to install them all, whether it's download or build them. It's going to now resolve them all. And here it found that these were already installed based from our previous example, where we simply wanted to consume them. This is a really great example of we don't have to re-download or rebuild the binaries. We have one cache and it will service all of the Conan projects on the machine if they're using the same configurations. So here, I'm not going to go through the CMake log, but it's effectively the same as before. Sorry for the scrolling. And we see here at the end now calling the package method. So it's finished the build. Now it's calling package. And as we said, we use the CMake install target. And we see that it installed or captured to the package folder our binary, regex_exe. And it put it in a bin directory, which is the traditional directory for binary executables. That is inside of, this is the package ID I mentioned earlier, how it's a part of the package folders. And that is inside of our Conan cache, which is under home conan.conan, or this is the username. So So this gives a little glimpse into the package cache folder structure. We're not going to focus on that right now, but it's not a bad thing to see. And finally, it gives us a summary that it packaged one file, regex.exe. So now, as we said, that's great. We now know that we have a package of this regex executable, but now I want to run it. I want to test it. I want to interact with it a little bit, make sure it works. So we're going to make a run directory for that. We're going to make a directory called run Linux. Then we're going to run this install command that we said. And I have a slight typo on the path. And that generated more of those environments I told you about. We're not going to cover, but I'm going to use one of them. Excuse me. And now my shell has on its path this directory. The directory where the directory where the binary is for our application. So now when I run regex.exe and pass it the string we did before, we get the output. And if I say which regex.exe, it will show you that it is running it from the Conan cache. So the binary we built, it's trivially easy to execute those binaries. And in truth, if there were other applications, say inside of the Boost directory, like tools or in the OpenSSL directory, we would get those on our path as well. And we could run any executable which was in our dependency graph. So it's a very neat and novel feature. And it's the best way to test and demonstrate this little example. And now I'm just going to clean up briefly, going to. Now that was for Linux. We have effectively an identical demo on the Windows side. I'm going to run that very quickly. Again, you can see in green that the differences are mostly cosmetic and related to just the shell versus the bat. So give me one moment. All right. We create our package, but now using the Visual Studio profile, the Microsoft profile. And it really is this easy that you can have, it's trivially easy to just take the same source repo and build and create packages for any of the platforms that you support with the same command line syntax. And many organizations who work in teams who have a lot of projects, they build a Python application sort of module, which makes these little setup commands cross-platform, so you don't have to worry about the shells. You could do everything in native Python. It's a little easier. I think I failed again on the path to the profile. And again, we activate run. We have this virtual environment called the run environment. And now when we run our executable, the name's a little different. It's now got a .exe because that's Windows. And we get our result. We get the sort of modified text. Okay. So that is our create package example. The final example we want to do, well, let's briefly summarize what we talked about. There was kind of a lot. We jumped across multiple platforms. We showed multiple Conan file recipes. I do want to just recap briefly. We have the Conan file is the recipe, and it is the instructions for creating the package that includes building applications from source and invoking build systems. It's a Python class with very standard methods. They're all invoked in order, and you can check the documentation for what that order is and all of the various optional additional methods that exist. We only showed the basics, but there are more for more complicated cases. And yeah, that's the basics of a recipe. And that is the process of working with a recipe, and also in a cross-platform way. So finally, you make a package. The next exciting thing to do is to upload it and share it. So whether you're working on an open source library and you've now shared, you want to share the package with the community, or whether you're building components internally for a company and you have a central repository for internal developers with private packages and private components, Conan upload is like the next major important thing you need to learn. So we're going to do a few commands here related to dealing with remotes. If you work with Git or any other package managers, some of these will seem pretty familiar. Conan remote list shows all of the remotes that are currently configured on the local machine that your current client knows about. Conan remote add lets you add new remotes to the list, so you can have any number of repositories that you can work with, and that's a simple command for that. And what we're going to do in our example is add a repository from our demo environment, which, as I said, we're going to stand up a JFrog Artifactory CE server, which is a free community edition of Artifactory, and it's designed specifically to host Conan repositories. And we're going to spin that up now, and then we're going to upload to it. And the operative command in this exercise is Conan upload. So let me jump over to the command here, which we will use to stand up our environment. CD to
font a bit bigger if you can, please.
Yes, I apologize. So so the command I ran is here once again. Teaching Docker, or if you don't understand Docker, it's outside the scope of this course. It's a pretty cool tool, and that's why we give you the commands in the slides. You don't really need to know it. You should just be able to run these commands safely and get your environment. So that one's actually going to take a moment. While that provisions here, let me see if I can keep that down and over there. I'll just minimize it. So the Conan remote list is the command. We're just going to simply show the list that comes by default with Conan. Then we're going to add a new remote, which points to our server. Here's the address of the server. It will be the same address on your machine in your environment. And notice here at the end, this Conan-local. So on servers which host repositories, you can give repositories a name, just like a Git repository or anything else. So the repository name we've chosen here is Conan-local to indicate it's on a local server instead of a remote out in the cloud. The next thing we're going to do is log into that remote. So we're going to use the Conan user command to provide credentials for a given remote. In this line here, we've done Conan remote add Artifactory. Artifactory is the simple text name, the local text name that we're giving to this configuration of this URL. So now when we say Conan user, we pass -r Artifactory, which is the name. So we're saying we're giving a name and password for this remote. And then we're going to upload our regex package, again specifying very specifically, we want to upload it to this remote named Artifactory and not say somewhere on the public internet. And then when we're going to do a search, we're going to search for that same package reference or recipe reference. And again, we're going to search it from our local Artifactory. Let's see if our environment is up yet. This one takes a little while, so I'm glad you're seeing that now. If you choose to reproduce it on yours, your environment, your machine, it may also take a little bit of time. I will, there we go. It is done now. So now I will switch back over to one of the other shells. Actually, I'll just, we can use this shell. On our Windows machine, we want to, what we're going to do now is actually interesting. We're going to run these commands once on our Linux environment and then once on our Windows environment, which in my case is my local environment. And we're going to upload the two different binaries that we built for the regex package to the same repository. And we're going to show in the search that under that one recipe reference of regex 010, we have a Linux binary and a Windows binary. So let's do that now. So let me grab the commands. Conan remote list. So I actually have many different remotes on my machine. In our, let me see here. Oh, there it is. This is our, we're back here in our Linux shell environment. And if I do the same command here, we see that I have only ConanCenter. Should have started there. So now we will Conan remote add Artifactory and the URL of our remote. And we will log in with this command. It gives us a nice confirmation that we were previously anonymous and now we were logged in as admin. And now we could do our upload command and we specify the full recipe reference of what we want to upload. Of note, --all is a flag that we add to say, upload all of the binaries that exist, all the configurations for this package for my local cache to the server. You can also upload just a single configuration or you can just upload the recipe. We're uploading all the binaries from the Linux environment here. There happens to be one. So it does give a nice little, the log is pretty good about telling us what it's done and how big the files were and how long they took. So we're successful. Now we'll do a Conan search from the Linux side and see what exactly exists on our remote Artifactory server. Okay, we have a package with a current package ID, and these are the settings that it knows that were used to build that binary. This was in fact GCC 7 on Linux, and it also tells you what all of the dependencies were. So this is a very great search feature, and it tells us, okay, we have one binary for this package. So now we're going to Control-Shift-O, and we're going to go over to our Windows environment. We're going to do the same commands. We're going to add Artifactory. Line jump. We are going to log in. Oh. We have here a slight bug in the networking. So actually, unfortunately, we are not going to be able to show that part because I have an issue with my local network. So we're going to skip that part. Apologies. What I will say is that in the output of the Conan search, you would simply see a second package ID with a different configuration. It's not that exciting, but it is helpful to see, and that is how the feature works. So behind this recipe reference, we can have any number of binaries, as we said originally. So that is the upload a Conan package exercise. Again, the key command is Conan upload. It's very straightforward. They're easy commands for managing remotes, adding, listing, and removing, and logging in. We explained that this strategy of local and remote repositories with simple commands for downloading and uploading is similar to other package managers, which we think is important. It provides a practical and familiar experience to people who are usually working with builds and lots of builds. There are other package managers out there for C and C++. Some of them do not work like this at all. They're very different, and we feel that this familiar experience is important. Finally, we demonstrated how Artifactory CE provides great free and local hosting for Conan repositories, and how fast and easy it was to set up. We spun it up in, I think, less than 2 minutes. So it's very easy for you to get started. If you want to start hosting Conan repositories and working with packaging locally, it's very trivial to do. So that's all the exercises I have, which is honestly a shame because there's so much more to show in Conan. With that said, here are the best places you can go to learn more about Conan. We have on the homepage at conan.io links to each of the following resources. So obviously the GitHub project, we have a blog and documentation. We have ConanCenter, which is where all the open source recipes and packages are. And then we have the Academy of courses we mentioned. And finally, Slack. As we said, we're one of the busiest channels in the C++ community Slack channel. So each of these is valuable in its own way, and depending on your environment and interests, we hope you'll find them helpful. So also, if you want to chat with me, the Conan team, or the other Conan users, again, Slack is probably the best place to go. So that's it. In closing, I really want to thank Mihai and Pavel for allowing me to come and present to you all today. I hope the session was enjoyable and informative and not too long. But if so, please feel free to mention us on Twitter or LinkedIn. In any case, at this point, I'd be happy to take any questions or comments and remind you about the link to sign up for the free t-shirt raffle.
Thank you so much, Jerry, for giving this talk. It was very interesting. I would ask everyone to do a virtual round of applause, but...
Oh, that's not necessary. Yeah, so I said we could take questions. We already have a bunch of questions that I did want to address. Okay, thank you so much. I'm going to go in reverse order, most recent first. ConanCenter, is it possible to install private owned instance? Good question. It is easy to download packages from ConanCenter and push them to your own instance. There is no turnkey way to say clone the entirety of ConanCenter. All of the recipes in ConanCenter are stored in a single Git repository. So that's helpful. If you want to get any recipe that was used to build any package, you can go to the ConanCenter index on GitHub, which again is available through our homepage. And oh, Diego makes another great point. So in addition to, say, recreating or building all your stuff from scratch, if you want to proxy and cache packages you use locally, but on a server that runs in your environment, you can do that. Artifactory has a great feature that can cache packages, and you can read more about that at the documentation. But basically, it means so that if you if your internet goes down and you don't want your builds to break, let us know. Continuing up, you want to check ConanCenter. That's Diego. Let's go back. There was a question early. I think many of these other questions were answered. Any current support for MinGW GCC on Windows? Diego, did you answer that? Yes, it is possible to build with MinGW. Packages in ConanCenter will not contain binaries for MinGW in Windows. So yeah, we limit the pre-built binary list a little bit. We don't build all of we don't build with Cygwin or MinGW on all of these platforms, but the general idea is that the recipe is capable of building for MinGW. So it's just a matter of setting up your own build. Or if you want to use CI to build our recipes, that's the best process. So Roy, you asked a question earlier about, can you speak a little about conventions of build names, such as debug and release, and then also it says compiler choice, and how naming gets paired. If you want to add any clarity to that question, that would be helpful. What I can say is, in general, and Diego, I'm glad you're here to correct me if I'm wrong, but in general, Conan models the release and debug build types, but also the rel with debug info, which is a common name of a build type in CMake. Yeah, Diego, if you have any thoughts on.
So, hey, Jerry, can you hear me?
Yes, go ahead.
Yeah, so this is Roy. I think my question might relate to what you referred to as profiles, and just the fact that different libraries have different names, like 64-bit versus 32-bit.
Oh.
Debug, release, etc. And does everyone that uploads their package to Conan literally just align themselves with their own naming, so that once I'm in the Conan environment, I know what naming to expect, or will I need to know what naming to look for, or what dependencies to get from either like a boost or an app cell, and know their own names for profiles? Yes.
Great question. Okay, so that makes it a much easier question to answer. So within ConanCenter, builds are done either with the name of release or debug. The two build configurations we support are release and debug. And so no matter what the package is, et cetera, no matter what the name, those values are built in, and they're hard coded into a file called settings.yaml in Conan. And if you're building packages privately and you have different conventions and different notions of these build configurations, you can modify that list. You can get rid of release and debug and create completely new configuration names, or you can add to the ones that we have. But so it's a very extensible configuration model. But by and large, release and debug are like the two almost always used. I don't know of anyone using rel with debug info, but Diego, I'm right that is an option in the default settings.yaml. Is that correct?
Yeah. I've linked the default settings.yaml. I've put a link there. So it contains the 4 typical CMake configurations. So let's say that settings.yaml contains the typical built-in definition of the space of possible definitions. And the profiles should take values from the settings.yaml. If you modify the settings.yaml, you can have your own values for your own profiles. And you can manage both of them at the same time. If you are working in your company and you modify your settings.yaml, you will also have your own profiles with your own values. And you typically distribute both the settings.yaml and your profiles with a feature that is called Conan config installed, that allows you to share your configuration with your team and CI machines and everything. So all of your Conan instances are aligned to the same settings and to the same profiles, even if they are custom ones and they are not the mainstream Conan ones.
Did that answer your question, Roy, at all?
Yes, I think so. Thank you.
I wanted to add too that by default, when Conan makes a match, which we talked about very early on for a configuration, and I think I will use the opportunity to go back there for that slide. If you build with release, a configuration, for example, release, there we go. Conan will by default look for pre-built binaries for all of your dependencies with release. It'll look for the release builds of all of those dependencies. Similarly, debug, if you say settings is, if in your profile it has debug, it will default to debug binaries for all of your packages in your graph. However, at the command line or in a profile, you can override on a per package basis whether you want the release or the debug. So you can say, yes, I want everything released, but I want the debug libraries for bzip2 for some reason. Or conversely, you would say, I want a debug bzip, or I want, you know, everything debug, but I don't want debug boost because I just want the release build of boost with all these other debug. So you can select on a per package basis. It's very flexible. You can mix and match. Now, whether or not that technically works, some cases those things won't work together under certain circumstances with certain compilers and things like this. However, you as the author get to override the match, or as the caller. Were there any other questions I missed?
Yeah, Jerry, there are a couple of new questions from John and Evgeny.
I feel like I missed those. Let me go bring up the
Yeah,
chat again. So I didn't see any recent exploit published by Microsoft regarding hosting of private packages. So unfortunately, I have no comment on that. I can follow up after, but thank you, John. And then also, can you say some comparison features for Conan to VC package or Choco, pros and cons? Great question again. I could speak to this one a little bit. So I think one of the biggest things to keep in mind with a comparison of Conan to VC package and Chocolatey is different. I'll compare that one separately. Is just how fundamentally different I think Conan and VC package are in both their design and in their goals, and I think in their target audience. So as we said earlier, there's a couple of features we mentioned about Conan that are really important. So this architecture here was specifically one of them. This concept of remote repositories and local repositories and the ability to push and pull from a remote is a very familiar thing. It's a very straightforward thing, and it's what people think of when they're thinking of package management in general. And then again, the big innovation for Conan is that you need to be able to, for there to be a simple notion of boost, a boost package that works across multiple platforms, you need something like this innovation of package ID, which is very specific to Conan. And I think it is one of the defining characteristics of Conan, is this mechanism for storing and organizing and matching between different binaries in a cache. So cache management is a feature that doesn't sort of cross-platform flexible cache management of native binaries is a feature that doesn't really exist in the other package managers, and in particular VC package. And now Chocolatey, and there are other differences as well. Yeah, I mean, we could talk for a long time about that. But so Chocolatey is a great third example to compare to, where Chocolatey is actually under the covers. It's just a NuGet repository, which is a established package management repository for .NET. So it's almost like comparing C# package management to C++ package management. However, Chocolatey does understand a little bit of like multiple architectures. However, one of the biggest differences is that Chocolatey, when you have a package and you want to package multiple architectures, you generally put them in the same zip. So all the binaries effectively get packaged together. Now, there are other ways to do that, and I don't actually claim to be a Chocolatey or NuGet expert, but there are, and maybe there are new features now that are starting to add, they're starting to get into this strategy that Conan has used. I think there's people who are studying Conan and learning a lot from it and trying to borrow features from it. But typically, when you had like 64 and 32-bit packages on Chocolatey, it was just one big zip that had both. And then at runtime, it would download both and choose one. And I think that's the state for most package managers, like other package managers. So, and then also Chocolatey, it's worth pointing out, that is used for system applications almost, well, primarily. It's very different from apt and from yum, and even brew, which sort of are in between and do both developer package management for the OS and applications for the OS. They sort of bring in libraries and applications, whereas Chocolatey brings in very few libraries and doesn't integrate with your build systems at all. It's much more application focused. Okay. Oh, great question from Roy. Can Conan be used to get the compiler itself, Clang, and compile it as a dependency? Yes, absolutely yes. Building compilers is a very complicated endeavor, but it has been done. We have many private companies and teams who have told us that they have packaged GCC and many forks of GCC and old versions and new versions, and they use them internally. There's also a public recipe for LLVM, for building LLVM within a Conan package. It is not in ConanCenter, but it is sort of a lot of people in the community have worked on it and work with it. Again, it's a huge project to build, and there are so many options that go into building it. It's hard to build a compiler in a general way. But if you want to build an internal tool chain that leaves nothing to chance, and it puts all of the compiler and all of the build tools inside of Conan packages so that your Conan package effectively describes everything it takes to build, you know, as low level as it can be, that is possible. And I do encourage people to do that if that's a thing that they need. So there's a question, can you specify test-only dependencies? So users don't have to say depend on Google test, but you can pull it in and run tests. The answer is sort of. We have a feature called build requires, which is a dependency that's only needed when you run the build system, when you run build from source. If you download a precompiled binary and you just use a precompiled binary, there's no, you know, the Google test won't download if you declare it as a build require. However, there is talk of improving our sort of conditional dependency features, and we have talked about a test dependency feature that we're looking at the feasibility of for Conan 2. So it's a really great question. But for now, it's pretty reasonable feature is to use test dependencies like Google test or catch as what are called build requires. And you can read about that in the documentation. I'm going to go to the end now. So Gary, so Roy asks, what about C++ 20 modules? Do you consider orthogonal to Conan more of a build system thing? My understanding, yes, I do consider it that way. I think a lot of people talk about it that way, but when I read modules, it is hard to believe that it's not going to affect packaging in any kind of way. Diego has thought and looked at this, I think, more than I have even. Diego, do you have any thoughts to add about modules and how it would relate to Conan?
Yeah, at the moment it's more like a build system thing. So it will be exposed somehow in the boundaries, but in the same way the headers are exposed. So there is no still, it's not 100% clear if the BMI files will be portable or not, but they can be generated or they can be packaged by Conan, because Conan will be able to package per configuration, per compiler. So even if they are not portable, Conan will associate them to a specific configuration. Conan might be able to package them. So my understanding is that Conan will not be that much affected, only in the way that build systems will change the way they build. Conan will need to adapt their build system helpers and all that stuff. But actually we had like a proof of concept, like 3 years ago in our blog. We were already creating packages with Visual Studio that had some, in 2016. And this is a proof of concept that is possible. As I don't know if you know, but Conan has been used to package Java code, to package Golang code, to package Python code. At the end of the day, it's just a recipe with build source package method. It can be used in a flexible way. So yeah, it's kind of possible. I don't think it will be very affected. And actually, I think it will be the opposite. It will be like a tool that will enable, it will make easier to adopt modules, because introduce the like separation of builds in some way. So yeah, we will be ready. When the build systems are ready, we will be ready.
Yeah, my hope, if anything, was that it might simplify for new code. It might, enable more assumptions to be made in the recipes, or safer assumptions to be made that were not possible before. But a lot of that remains to be determined. And worst case scenario, there's no change. best case scenario, we might be able to optimize some of our code and make things a little easier.
Yeah. The thing is, the distribution mechanism will still be libraries, not modules. So shared libraries, static libraries, they will not disappear. They are still the distribution mechanism for precompiled code.
Right. So something like what John has just suggested is like, could the package manager parse the source code to identify what packages are pulled in? So, you know, these are not the first time that feature has been suggested, that capability has been suggested. There are tools that do that kind of thing outside of Conan. But yeah, maybe in a future 10 years down the line with modules, where if everything had module support, unfortunately, a lot of Conan packages are C packages, and you know, C will not have modules. So it's tricky to imagine. So I think in a way, Conan as a package manager provides a good ceiling as far as a boundary of becoming too entwined with like implicit logic and implicit discovery, and like so things like smart linking, right? So Boost has things like smart linking, and a lot of packages, you know, inside the headers and stuff, they like tell what lib files to link with, and I think in a lot of cases that's proven to be more problematic than it is valuable. And so it's not like a universal solution. And with Conan, we would want things to be general and safe and cross-platform and backwards compatible. So something like that, like a really advanced feature, would maybe be a custom tool that you could write, maybe something that does that and then generates a Conan file based on your own discovery, but we wouldn't probably implement that in a generic way. Now, there's one other good question I see here. I don't want to miss it. Recommendations on how to rebuild all user libs when a common dependency is updated in a breaking way. Yes, this is a great question. It is the focus of our next course that's coming up in the JFrog Academy. It's the Conan CI course, because this is a problem very much related to continuous integration and automated builds with C++. So in general, the short answer that I will give you is that currently the status quo in the industry is that if you have a breaking change to a component, you should, and you have like a package boundary, like each library or component has a package, then you should increment the version number. And so then your consumers can all update their code and increment their version number when they adopt to your new API version. And so changes in the semantic version world should propagate in this way with incremented semantic version numbers. However, and Conan supports this case very naturally in the normal way. However, what enterprise teams at scale have told us many times over is that when you work on monolithic applications in particular, or in code bases where a bunch of components are changing all the time together, and when the common case means you have to change 3 components at the same time, like every week, that it becomes completely unmanageable to use semantic versioning in a strict way to evolve a large application like this. So Conan has a feature called package revisions, which is a big part of an alternative solution to this problem. So that now you can make changes which break a package, but when you do that, when you upload them under the same version number as the previous build, they will get a new revision, so they can be distinguished from the previous and they will not overwrite. And what that allows you to do is, say, have many different revisions of a certain version of a component. It doesn't completely solve the problem alone. There's more implications. So if you now have more revisions of a version, that's really just kind of a fancy way of having multiple versions. So there's another feature in Conan called lock files, which we focus on extensively in the training, which gives you a way to automatically control and move forward breaking changes and sort of thread them together and reconcile changes together across components when there are multiple breaking changes that sort of naturally occur when you have multiple PRs to a component, within a short period of time. So please look into our new training. Please look into the Conan features of revisions and lock files. because in there, so the thing I failed to say about that was that the feature of lock files will allow you to determine which downstream components need to be rebuilt and in what order when a given component changes. So yeah. Yes. Okay, good. I hope that made sense. If you'd like to chat with me more about that, you can catch me in the C++ Slack channel. Great questions. Diego, I'll let you field one of these. Do you recommend unit tests be packaged and uploaded with the Conan package and recipe?
I was answering in the chat, not in the general case, because if you're putting binaries in your library code, actually you might be changing the library. You are bloating your packages. We are aware that our users are packaging unit tests into packages, but they typically try to put in a separate package. So they keep the main package as the library only, and then they put the unit test and other tests into a separate package, so they can manage their product in a clean way, and only they keep those packages containing the unit test only for, let's say, policy, regulations, that kind of stuff. They need to keep those unit tests in storage somehow, and they use that package, but not typically inside the main library package. It's possible, but doesn't seem a clean best practice.
Diego, there's another question. Is Conan overkill for header-only libraries? I say no, not even close to overkill. All the normal features of dependency management still exist for header-only libraries. It's just one of the problems doesn't exist, which is multiple binaries, but you still have version conflicts that need to be resolved when you have daemon dependencies. You still need a way to gradually sort of move and instrument an upgrade through a code base. And I think a lot of our users have reported that this is problematic even for header-only libraries. These are big challenges for header-only libraries, and Conan bringing a uniform solution is helpful.
One of the strengths of Conan is that it manages different versions very easily. So as you were asking before against VC package, that it doesn't have this feature as built-in as in Conan, you can have multiple versions of the same header-only library in your Conan cache. And you can have 3 different projects using different versions of that header-only library in a seamless way. No conflicts. You can work with them at the same time. Very nice. If they have transitive dependencies, they were saying, they can detect version conflicts or other configuration conflicts. So even if you are only managing only header libraries, it has some value.
Also, a lot of header-only libraries generate a source file or generate a header or generate a platform-specific thing, which, you know, they're 99% portable, but there ends up being a header that is unique for each platform. And so, you know, that's an awkward case if you just want to do it treat header-only libraries in a simpler way.
Let's assume header-only libraries popularity is because it used to be difficult to handle dependencies. Now with a package manager, we really want to improve our compile times, and we shouldn't be abusing header-only libraries that much as we used to.
Very good question from Alex. The question is, if the library provides its own findmylib.cmake file, will the Conan package reuse it, or will Conan write a new one? And this is a complicated answer because, as we said, CMake actually has a few ways of using dependencies, and there's policies, and different versions of CMake have slightly different behaviors. But the short answer is that most of the time, if Conan tries to use built-in CMake find modules, they will fail or they will produce unexpected results that you might not even notice. One of the challenges is transitive dependencies. There are a lot of other challenges. Maybe Diego wants to expand on a bit more, but yeah, we generate find modules for all the open source stuff that we package in ConanCenter for various reasons.
So it is possible. If you want, you can package your findmylib.cmake, and we have the CMake paths generator that will allow you to locate that file and use it. but they have two fundamental flaws. First, transitive dependencies, as Jerry said, is easy that a fine CMake script can find the dependencies in your system instead of Conan package. So let's say you have Boost that depends on OpenSSL, okay, and you have an older version of OpenSSL in your system. The find package, the built-in find boost.cmake script will probably locate the system old OpenSSL version instead of the modern Conan one, because they are typically hard-coded to find OpenSSL in the system. Okay, that's the first flaw, which is important. Okay, it's a security issue. And the second one is multi-configuration. Find scripts, CMake find scripts are not prepared for multi-configuration, so you cannot have multiple binaries for multiple configurations, and find CMake find them. Okay, you can only find one of them, and if you are using like build systems as Visual Studio, that you can switch between debug and release and other configurations, that will not work. Okay, so if you want to have multi-configuration, you better use the Conan generated ones. But if you still want, you can, via the CMake paths generator, you can use the library CMake script.
And some people do. Some people have custom find package stuff, and they've, you know, they're doing custom environment stuff that the stuff that we're generating, which tries to be general, doesn't solve their very particular case. So yeah, that's why we have multiple mechanisms for CMake actually. If anyone has asked a question that we failed to answer, please repost it now. Otherwise, Mihai or Pavel, if you want to add anything in closing or...
Yeah, thank you again for all your patience and answering all these questions and for giving the talk. That was great. That was really brilliant. So having said that, I think we're good. I don't see any new questions coming in. I think we're just going to close it here. So if anyone wants to have any follow-up questions, please feel free to reach out to both Jerry and Diego and ask them in private or in the comments on the meetup page. And if possible, Jerry, would you be able to share your slides on the meetup page? If people would like to have a look at them.
Absolutely. You bet. You bet.
Thank you very much.
They're available at the link below, but we'll also make them available directly from the meetup as well. And also I wanted to add, if, you know, 6 months down the road or 9 months or whatever it is, if you would like to have us back to give a more advanced talk to this group, you know, where we did the basics today, but we didn't even really scratch the surface, let us know. We'd be happy to come back and talk about completely different stuff. Cool. Thank you for that. I'll add a reminder.
By then, maybe you can tell us about Conan 2.
Yeah, that's right. Yeah. We'll probably ping you when Conan 2 is released. That might be the case. So yeah, sounds good. Okay. Wow. Well, thanks again, everyone.